Hi, today we're going to talk about two different kinds of properties. One, the associative property, and the other one is the commutative property. I always add an end to it. I know it's not that. It actually, if you want to look to see what it looks like, we have, let me write this up, we have the associative property, which says that if you have A plus B plus C in parentheses, and that is the same thing as saying A plus B in parentheses plus C. And that those are the two, those mean the same things, so that you can just regroup things. So let's look at that in real numbers. So let's say 2 plus 3 plus 8. Is that the same thing as saying 2 plus 3 and then plus 8? Well, let's see if we look at this. 2 plus 8 plus 3 is 11. Is that equal to 5 plus 8? Well, 2 plus 11 is 13. Is that equal to 5, 6, 8, 9, 10, 12, 13? Is 13 equal to 13? And it is. So those two things mean the same thing. So let's change the font of these. Say 18, and we're going to put these down here. So the associative property says that A plus the grouping of B and C is equal to AB grouped plus C. Those are the same things, and that's the associative property of addition. It's actually true if I say the associative property is also true for multiplication. So the associative property is also true for multiplication. So if I say 3 times the grouping of 4 times 5, is that equal to the grouping of 3 times 4 times 5? Well, let's see, 3 times 4 times 5 is 20. Is that equal to 12 times 5? That is equal to 3 times 20 is equal to 60, and 12 times 5 is also equal to 60. So it's also true for multiplication. So the associative property is true for both multiplication and addition. It is absolutely not true for subtraction and division. Okay, so remember I was also talking about that funny word that I cannot say very well, which is I want to say the commutative property, but it's not, because it doesn't actually have an N in it. So commutative property. So this says that A plus B is equal to B plus A. So is that true for addition? All right. If I say 3 plus 4, is that the same thing as saying 4 plus A? 4 plus 3, and it is. 7 is equal to 7. So that is true for addition. Well, let's check to see if it's true for multiplication. So is A times B the same thing as B times A? Well, 3 times 4 is the same thing as 4 times 3. Those are both equal to 12. So it is true also for multiplication. And so that is the commutative property and the associative property for addition and multiplication. Okay, I have 3 other properties that I wanted to talk to you about. And one of them is the additive identity property. And this is, so think about what the actual property says: additive, which means addition, identity. So it means that whatever you take and you add to, you're going to end up with the exact same thing. So A plus something has to equal A. Well, the only thing that can possibly be true for is 0. So A plus 0 is equal to A. And that is the additive identity. Another property, actually, let's see. Another property that we sometimes talk about is called the multiplicative identity. And this is the same thing. It says that if I take A and I multiply it by something, it has to equal A. Well, again, the only thing that could possibly be true for is 1. If I multiply A times 1, I have to end up with A, which that it is the multiplicative identity. The third property that we want to talk about is the multiplicative property of 0. And that basically says that if I take A and multiply it times 0, it is always going to equal 0. So no matter what I multiply 0 by, I'm going to end up with 0. So those are the 3 other properties that I wanted to talk to you about. Okay, so why are we talking about all of these things? We're actually starting to talk a little bit, introduce you guys a little bit to the concepts of proofs. If you're writing something and you claim something to be true, if you're writing an essay, usually at some point along the way you have to defend why you think it's true. And mathematics is no different. If you are going to say that while you're doing math, there's actually reasons why you're allowed to do the things that you're allowed to do. And in order to prove that those are okay, you write up what this thing is called a proof. What we're talking about now is the basic introduction to proofs. We're probably not going to get much farther than this, but this is probably going to be your first taste of proofs. And when you end up in geometry in high school, you're going to go back and say, oh yeah, Mrs. Whitney talked to us about this. I kind of remember something about this a long time ago. So one of the things that we're going to talk about is something called a counterexample. And a counterexample is how you prove that something is false. So if I say, is something true or false, if you gave me an example, that would be that would show me that it was true. But if it was false, you would need to provide something called a counterexample. And actually, I think that is one word. Okay, so a counterexample is a way of proving that something is false. So for instance, we were talking about the commutative property being only for multiplication and addition. So would it work for division? So is the commutative property good for division? Well, let's see. If I have 15 and oops, where's divide? I don't really have a divide, so we have to use this. Divided by 3, is that the same thing as saying that 3 is divisible by 15? Well, 15 divided by 3 turns out to be 5. Is that the same thing as saying 3 divided by 5? No, not really, because that's 1/5. So the two of them are not equal. So that would be a counter example to saying that the commutative property works for division. It doesn't. Here's a clear example of how it does not work. So let's place this down as a counter example. Okay, so why don't you try this on your own? We're going to use a got it, and I want you to tell me whether or not if the difference between two numbers is always less than both of the numbers. Is this true or false? And if it's false, provide me a counterexample. Okay, pause the video and go see if you can think of a case where that might be. Oops, that ends up being really large. Okay, so let's find out if that's true. All right, well, what happens if I take 8 minus 2? That is equal to 6. Well, is 6 always less, is it less than 8 or 2? Well, no, it's not. It is less than 8, but it is definitely not less than 6. I mean, less than 2. So that would be a counterexample of how that is not true. So it's false because 6 is not less than 2.